This is 1.5 visualize fractions, and so these are the items that we're going to be working with today. Equivalent fractions, simplifying fractions, multiply fractions, and divide fractions, and then simplify expressions written with a fraction bar, which is basically the same thing as this one here. We'll do most of our work on the simplifying fractions because that seems to always be the toughest. This one here, and this one should all be review from your previous courses. So let's start with our equivalent fractions. So I've got 7/8 here. I want to write a few equivalent fractions, or fractions that are the same as, that have the same value as 7/8. I can simply multiply this by, let's choose 2 over 2. Now remember, this 2 over 2 is equal to 1. So I'm essentially multiplying 7/8 times 1. I'm not going to change the value of 7/8. What I am going to change is the way that it looks. And if you remember correctly from your previous courses in math, the way we multiply our fractions is by, we multiply straight across 7 times 2, and then we'll do 8 times 2. So it's the numerator times the numerator, denominator times the denominator. And so we'll do that real quick. So we get 7 times 2, that's 14. And then we'll do 8 times 2, that's 16. And so 14/16 is an equivalent fraction. This fraction right here, 14/16, is an equivalent fraction to 7/8. They have the same value. They would be at the same location on a number line. So let's do another one. 3/4. We'll multiply that by, say, 5/5. Again, I'm writing an equivalent fraction, so I want whatever is there to be equivalent to 1, and this is equivalent to 1. 5/5 is the same as 1. And so I'm going to multiply straight across. I'll get 3 times 5, that's 15, and then 4 times 5, that's 20. So that's how we can write equivalent fractions. Alright, we're going to simplify some fractions now. So this is really, really important. We need to know how to do this, and we need to know how to do it well. Essentially what you're doing when you're simplifying fractions is you're going to find the GCF, the greatest common factor, of the numerator and denominator, and you're going to divide that out from the top and the bottom. Many people do this different ways. Most of us, from what I have seen, we simply look at the numerator and the denominator and we go, ooh, 2 goes into both of these, and then we divide out a 2. And then we do it again. We go, ooh, 2 will go in, 3 will go into that, and then you keep going from there. It's not the most efficient way of doing it. You could list or determine the greatest common factor for both 54 and 72 by writing the prime factorization and then going through the process of finding the GCF. I find the most efficient way of doing this is to simply write 54 and 72 in their prime factorization as a fraction, and I'll show you what I mean by that. So let's take a moment. We'll do our little factor tree here for 54. So that would be 2 goes into 54, and it goes in 27 times, and then 3 goes into this 9 times, and then 3 and 3. So the prime factorization for 54 is 2 times 3 times 3 times 3. 72, prime factorization for that, well, it's even, so 2 must go into it, and that's 36, and then 2 and 18, 2 and 9, 3 and 3. So this is 2 times 2 times 2 times 3 times 3. So there's our prime factorization for 54 and 72. Notice I still have it written as a fraction because 2 times 3 times 3 times 3 is equal to 54, and 2 times 2 times 2 times 3 times 3 is equal to 72. So this whole fraction here is equivalent to 54/72. All I've done is just written the numbers as prime factorization. So now what we'll do is we are going to go through and find common factors. So this 3 and this 3 here, those will divide each other out. 3 divided by 3 is 1. So they'll cancel each other out and become 1. So this one becomes 1 and 1, This 3 and this 3 cancel each other out and become 1 over 1. This 2 and this 2 will cancel each other out and become 1 over 1. And so what I'm left with in the numerator is 1 times 3 times 1 times 1. And you have to remember that those numbers don't just disappear or become 0, they become 1s because it's 2 divided by 2, 3 divided by 3, and 3 divided by 3. So now what do we have left? I've got a 3, I've got a 2, and I've got a 2. So my fraction has now become 3 over 2 times 2, and it's an equivalent fraction to the 54/72. So this is simply 3/4. That is the simplified version of 54/72. Now, this is a very visual way of simplifying fractions, and it's a pretty efficient way of doing it as well. So let's try the 12xy over 18x. So the prime factorization for 12xy is going to be 2 times 2 times 3 times x times y. And 18 is 2 times 3 times 3 times x. So we'll just go through and we'll cancel out common factors. So the 2 and the 2 become 1. And when you cancel them, if you cancel them like the way I have here, it looks like the red dash just looks like it becomes a 1. So this becomes 1, this becomes 1. And the x and the x. And so what we're left with here is 2y over 3. And that is the simplified version or simplified fraction for 12xy over 18x. So we already talked about multiplying fractions. You just multiply straight across. You can cross cancel if you know how to do that. I won't show that here, so we'll just do multiplying straight across. This is going to be 1 times 3 is 3, and then 2 times 4 is 8. So half of 3/4 is equal to 3/8. I should make that 3 better. So there's our product right there. Now dividing fractions, you're looking for, in this case, how many 7/24 are in 11/12. And so that's a little hard to visualize. You can actually do that. You can visualize it with make a little diagram. It takes a long time to do that. But if you think about like 24 divided by 6, this is simply saying how many 6s are in 24. And you can rewrite this as a multiplication statement. 24 times 1 over 6, which is 24 over 6, which gives you 4. And if we use this part right here, where we know this 24 divided by 6 is equal to the same 24, but I changed this to multiplication, and then I changed the 6 to its reciprocal. Reciprocal is just switching like this here, 6 over 1, switching the numerator and denominator. The reciprocal of 6 over 1 is 1 over 6. So what we can do with our problem here is, if I match what's going on with the 24 divided by 6 over there, I will keep the 11/12 where it is. I will change the division to multiplication, and I will write the 7/24 as its reciprocal. And now I can go ahead and multiply straight across. In this case, I am going to take a moment and cross cancel, because 12 and 24 have a common factor of 12. I can do a little bit of simplifying here. So this divided by 12 is 1, and this divided by 12 is 2. And so now what I have is 11 times 2 on the top, that's 22, and 1 times 7 on the bottom, that's 22/7. So I did end up doing a little bit of cross canceling just to make things a little bit easier on us here. Right, this simplifying expressions with a fraction bar, it's basically order of operations, and then we have to do a little bit of simplifying of fractions at the end. So we're kind of combining order of operations and simplifying fractions. So first what we're going to do is simplify our expressions that are in the numerator and our expressions in the denominator. So the expression in this first one in the numerator, that's going to be 49 plus 1 over 60. And 49 plus 1 is 50 over 60. So now we've got our fraction written, and we can take a moment and just simplify that. And the way that we'll do that is we will write the prime factorization for 50. So that's 2 times 5 times 5. And then we'll do the same for 60. And that's 2 times 2 times 3 times 5. And now we'll go through and we'll cancel out common factors. So 2 and 2, 5 and 5. And what you're left with is 5 over 6, which was pretty obvious to see. Now what you'll notice, something else that's interesting here, is what we cancel out on the top, we canceled out 2 times 5. We canceled out a 2 and a 5 here. So we canceled out 2 times 5, which is 10, on both top and bottom. And that is, in fact, the GCF for 50 and 60. So what you end up canceling out when you're simplifying this way is your GCF, if you care to notice. Okay, so let's simplify our numerator in this next one, and we'll simplify our denominator. Alright, so we'll do that. Let's see, so we have to do the stuff in our parentheses first. So 9 times 7 minus 3 times 12 minus 8 is 4. And we've got 8 times 7 minus 6 times 6. So we'll do 9 times 7 on the top, 63 minus, and I can do the 3 times 4 here. This is just 12. And then I can do the 8 times 7, 56 minus 36. And 63 minus 12, that is going to give us 51. And then 56 minus 36, that's going to leave us with 20. And so we'll simplify the 51/20. I can write this as, in its prime factorization. So what do we have here? 3 times 17 on the top there. And then on the bottom we have 2 times 2 times 5. Now what you'll notice is that I don't have a common factor other than 1 here. So that means that 51/20 is the simplest version of that fraction. And so we can just leave it like that. Now, I don't mind if you guys you'll notice this is an improper fraction here. I don't mind if you leave it improper. That's totally fine with me. No need to change it to a mixed number. Okay? All right. If you have questions, bring them to class, and we can talk about them. Have a great day, guys.